So hello students, today we are going to start um, the solid mechanics from module 1. So in module 1, the first part we are going to discuss today, that is the material properties. So here among the material properties, some important topics that today I am going to discuss with you, and please listen carefully, and later on I will give you some illustration. So the solid mechanics, it deals with deformable solid bodies, we can say much precisely. So important properties and their reactions under that, namely elasticity. I will write it over here. Elasticity, plasticity, creep, and fatigue. So these are studied in solid mechanics. The application of solid mechanics is to implementation of design of machine parts and structure, as well as the modes of failure in it. So please remember, so what are the applications? You can just unwind and listen to me once again. Okay. So for axial loading like tensile or compressive, universal testing machine or UTM is used. So in case of ductile material, the yield point is what to say, that is, it is very much precise. So we can find it out at a particular and specific point, while for brittle materials, the point of brittle fracture under tensile load is noted again. For the condition of plasticity, we must understand all inelastic deformations are not always plastic deformation. Please remember, all inelastic deformations are not plastic deformations. Okay, so please remember that thing. Now different methods of deformation that I can show you, that what are the different modes of deformation. For example, here one particular graph I have shown where the stress is given in the y-axis and the strain is shown over here in the x-axis. So first, the first one, this one, which is red or pink in color. So you can consider that it is a elastic type, it is a brittle type of failure. So you can call it brittle failure. I have exaggerated this top portion where you can clearly see that there is a clear-cut deformation, although we know very well that the deformation length will not be that much, isn't it? So it will be very short and small span of deformation at the end, and then catastrophic failure or sudden failure that occurs. The second one, that is the straight blue colored line, that indicates the linear elasticity. So if when it is under strain, then the stresses will accordingly change, and when it is actually the external loading is removed, it will return back by following the same path. Condition is it is within the elastic limit. So if it is within elastic limit, then it will follow the same path. So we can call it as linear elastic. So it is a linear elastic pattern of curve. Then the green one, that is the third one, over here again we can say that when the loading is done, then the strain is produced, and accordingly the path is shown over here, and when the external loading or external load is removed, then again it will follow the same path. The only criteria is that it has to just follow the same or similar type of elastic limit within elastic limit. So it is called as non-linear elastic. So it is called as non-linear elastic in nature. So we can understand that what are the different types of elastic, brittle, non-elastic, non-linear elastic, linear elastic, etc., etc. Now for elastic plastic type of material, for example in case of rubber, synthetic rubber or similar type of thing, what exactly happens when the loading is applied? We know that as soon as it is strained, the stress will be produced, the deformation will occur, and the curve or path will be something like that. So it is called as elastic plastic. We can observe over here one particular thing, that there is a prolonged plastic region rather than the elastic region. But the most common one, which I have not discussed till now, so if we discuss about the most common one, so it somewhat looks like this, then followed by a small curved line like that. Okay, so it is much more realistic, and it is called as, it is a ductile pattern of the elastic curve. So these are the different methods of deformations which are shown in this particular diagram. So over here we can observe that there are 5 different patterns of curve, okay, from elastic plastic to brittle, or in the reverse order we may express them also. But one important thing to note over here, the plastic flow can be given and understood by the indentation test. This is very important. Now initiation of plasticity is given by one particular equation which I am going to write over here. You can just check and follow. This particular equation is very important, that is sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 square, that is equal to twice sigma y square. So this sigma 1, sigma 2 and sigma 3, they are all principal stresses. Please remember, I repeat once again, that this sigma 1, sigma 2, sigma 3, they are all principal principal stresses. And what about sigma y? Sigma y is nothing but yield stress. Okay. So is there any name for this particular equation? Yes. It is called as Mrs. Henke equation. M-I-S-E-S, Mrs. Henke equation or Mrs. Henke criteria. Okay. So this is the Mrs. Henke criteria. Often we use this particular criteria for the designing purpose in case of machine design, analysis of material properties, its elasticity and plastic behavior analysis. So it is a very practical approach. It is less theoretical and more practical approach for analyzing the material property under different type of loading condition and when it is under different type of strain condition. Why I am emphasizing on the term strain? Because you know very well that if a body is strained, then only the stress will be generated within the body. So strain comes first, then comes stress. So that is why we are emphasizing on the term strain. Now on the other hand, hardness, ductility, malleability and toughness are the other governing parameters. Remember very well what I am talking about. Hardness, you know very well, it is a surface criteria. Ductility, malleability, and next that is toughness. So these are the criteria that we need to study, but these are the secondary parameters. But the most important factor among this is obviously creep. You will be studying in detail about the practical application example, goods and bads of creep when we are going to discuss in kinematics and theory of machine as well as in solid mechanics on the later half. Now it is time and temperature dependent parameter, this creep. It is a time and temperature dependent parameter, and it can create permanent deformation under constant load over a long period of time of application for a certain loading condition. So under creep, the material failure can occur depending on the time and temperature also. I mean time and temperature, that also becomes a very important governing factor. So this is the first possible introductory session regarding module 1. In the next session, we are going to discuss about the relation between resilience and toughness. So thank you for today's class. Study well, follow the notes, discuss, and best of luck. See you soon.